In a linear programming problem, generally we have m number of constants. With respect to one of the, with respect to the constant, m number of constants, we have m number of basic variable. Generally, the basic variables are either slab variable or the artificial variables, as you know. So we have m number of basic variables. So with respect to the m number of basic variable, we have a basis matrix of size m by m. So initially the basis matrix is identity matrix and inverse is known, the same identity matrix. So BC is the new basis matrix which is identical to B except, let us say, for the column R. This R can be 1, can be 2, can be 3, can be m also, because we have m number of columns. This one of the column is different. C is the, let us say, the C is the rth column of the basis matrix BC, the only column which is different from those in basis matrix B. So again I am repeating, B is the original basis matrix. It is an identity matrix. Size is m by m and its inverse is known, same identity matrix. So in the basis matrix B, there are m number of columns. One of the column we are changing with a new column. The reason is, in the simplex method, when you start the computation, in the initial table, this basis matrix is an identity matrix. This basis matrix is an identity matrix. And see, when we are talking about this, let us consider, we are considering the extended simplex table. If you consider the extended simplex table, then all the columns are there. Basic columns with respect to non-basic variable, columns with respect to the basic variable. See, columns with respect to the basic variable will find a basis matrix. Okay, I will explain with some example. So once this B and BC are known to us, so we are going to compute the new inverse in this manner. So let us define E, a vector E, a column vector E. This has exactly m number of elements. This column vector E we obtained using this multiplication. B inverse means that is identity matrix. So we multiply with, initially it is an identity matrix. So we multiply with the column C. If you multiply with the column C, B inverse into C, that is our column vector E. Column vector E. So the elements are the column vector. It is given, say, E1, E2, ER minus 1, ER plus 1, up to EM. This transpose, row transpose means it is a column vector. The elements are E1, column wise, E1, E2, ER minus 1, ER plus 1, EM. This we have obtained after multiplying B inverse with C. Once this is known with respect to that E vector, E column vector E, we are computing a new vector, new column vector. Let us say it is eta. This eta, the eta is defined as a column vector E1 divided by ER with a minus sign, E2 divided by ER with a minus sign, and so on, say ER minus 1 divided by ER with a minus sign. And since you are considering the rth column, so if you multiply B inverse with C, the rth column with respect to the rth column, So in the column vector, the rth element is ER. So the ER is becoming 1 over ER. So then next element, and there is no minus sign here, next element minus ER plus 1 by ER and so on say. Finally minus EM by ER, and this ER we assume this is a non-zero element. ER is non-zero and this is a column vector. Once E you have obtained, with respect to E you can find eta. So from E you can find eta. Once eta is known, we compute. So another matrix that is known as ER. What is ER? This ER, the ER is nothing but an identity matrix, and this rth column we can replace with eta, this eta vector. The ER is an identity matrix, exactly an identity matrix, but its rth column we can replace with the vector eta. Okay, so once we are finding the ER, we can write BC inverse equal to ER into B inverse. BC inverse equal to ER into B inverse. This B and B inverse are known. Initially, B and B inverse are identity matrix. So since B inverse is an identity matrix, so BC inverse will be ER. Initially, it will be ER. Okay. So the BC inverse is nothing but the inverse of the basis matrix BC, and B inverse, as I told, this inverse of the basis matrix, and ER is nothing but an identity matrix. With its rth column, we are replacing with eta vector. Eta vector. Again, I am repeating. We find E. E is nothing but B inverse into C. Sorry. The E is nothing but, the E vector is nothing but B inverse into C. After finding E vector, we can find eta vector. So after finding eta vector, since this C, column C is nothing but it is the rth column of the basis matrix BC. So we define the ER. ER is nothing but an identity matrix whose rth column we are replacing with eta vector. Okay, this is the rule. Now I'm just citing few examples. So this example will clarify all things, all the points. Now see this example number 1. Example number 1. See, I am considering matrix of size 3 by 3. You can consider 2 by 2, 4 by 4, 3 by 3, any manner. Okay. So as you know, the B matrix is a basis matrix. It is nothing but an identity matrix. The elements, as you know, first column 1 0 0, second column 0 1 0, third column 0 0 1, and we have another matrix that is BC. This BC and B, if you compare the first column, this 1 0 0, and the BC in the BC matrix, the first column is 2 2 4. They are two different. Second column 0 1 0, and BC, the second column is 0 1 0. Third column 0 0 1, and here also in third column 0 0 1. But we find there is a difference. The difference is the first column. The difference is first column. So we can find the inverse of the BC. So what is given here, but I will explain you how we have computed BC inverse. So the BC inverse, as you know, I have told BC inverse equal to ER into B inverse. I am repeating again here. So the two matrix B and BC. Which column is different here? Which column? Which column is different?
First column.
First column is different. So since first column is different, I am naming. So the first column which is different, that is C1. C1 equal to, the elements are 2, 2, 4. The elements are 2, 2, 4. Okay. So see, in the first column, the elements are 2, 2, 4. So if the first element is 0, there is some problem. Why? As you know, the pivoting element in the simplex table cannot be 0. The pivoting element cannot be 0. Please note down, the pivoting element cannot be 0. So the first column is different. So B and BC, these two are the basis matrix. The B matrix is nothing but an identity matrix. BC, it is very similar to identity matrix, but only the first column is different. It may happen sometimes the second column is different, or maybe third column is different. But here, so if you compare B and BC, we find first column is different. Okay. So C1 equal to a column vector. There are three elements, 2, 2, 4, C1. With respect to C1, so we'll compute B inverse into C. B is a identity matrix. The special property say B inverse is also identity matrix. Same? Yes or no? B is an identity matrix. B inverse is also identity matrix. So, but in first attempt, there is an identity matrix. But BC is not an identity matrix. Okay. So here BC is a different matrix. Only first column is different. So we find C1, the first column, the elements are 2, 2, 4. With respect to C1, we'll find eta or eta1. First E. What is E? E equal to B inverse into C1. Even if you not multiply from the left B inverse, that is the same C1. But technically we are going to multiply, we are going to use some recursive computation. Always you multiply the inverse what I have obtained earlier. So presently B inverse in the identity matrix, if you multiply 1 0 0 0 1 0 0 0 1 with 2 4 2 2 4, we are finding the same column vector 2 2 4. Okay, 2 2 4. Now once 2 2 4 is obtained, that is our E vector. It has three columns, 2 2 4. Now with respect to the E vector, we are going to establish eta. What is eta? Eta equal to, in this manner, that is first column, this first element is 2. So we'll have the reciprocal 1 by 2. Now second element is 2. We'll divide 2 by 2 with a minus sign. That is minus 1. Third element is 4. We'll divide by 2 with a minus sign. That is minus 2. So we have here first element is half in the eta vector. Second element is minus 1. Third element is minus 2. The eta vector has three elements with respect to E. So now eta we are writing half minus 1 minus 2. Eta vector is defined. Now once eta vector is defined, we are defining a new identity matrix where the first column will replace with the eta vector in this manner. So the E1 is nothing but an identity matrix, but only you find here the first column is different. The first column is half minus 1 minus 2. So the first column we are replacing with eta vector. So we have got E1. Once E1 is this matrix is obtained, E1 is obtained, we find BC inverse. BC inverse equal to E1 into B inverse. BC inverse equal to E1 into B inverse. Since B inverse is nothing but an identity matrix, so BC inverse is same as E1. BC inverse is same as E1. Is it clear?
Sir.
Is it clear?
Excuse me, sir.
Yes.
Sir, how did you obtain eta? Because in the definition it is written V divided by ER.
No, okay, see here. Okay. Eta equal to minus E1 divided by ER. Then minus E2 by ER. See, which column we are taking here? In general, I am considering Rth column. In my example, R equal to 1. Isn't it? In my example, R equal to 1. If
Yes.
I am taking R equal to 1, you can see here, R equal to 1, the elements are eta in the E vector, elements are 2, 2, 4. Since R equal to 1, so with respect to the first column, the first element 2 will take reciprocal. So the 2 will be 1 by 2, and we are dividing the other two elements by 2. So 2 by 2 with a minus sign, 4 by 2 with a minus sign. As a result, we are getting half, minus 1, minus 2. Is it clear? I am coming to the next example, the second column.
Sir,
Okay.
Sir,
Yes.
Why we are selecting the, okay, it's written in the question.
See, in the simplex table, when we are using, let me say, we are using condensed simplex table. Okay. We have decided one vector is entering, vector. One variable is going, leaving. That is departing variable, departing vector. So the non-basic variable is entering. Basic variable is leaving. With respect to non-basic variable, we have a non-basic vector. So where you will find? In the indicator row. In the indicator row, we are selecting the most negative element. With respect to the most negative element, what we do? We find the minimum positive ratio. With respect to the minimum positive ratio, there is a key element. In the next table, the key element P is becoming 1 by P. And what do you do? And we divide with that P with all elements in the same column with a minus sign. In the same column, we are dividing by P with a minus sign. So if first element is our P, what will happen? In the next table, the P will be 1 by P. And other element you divide by P. Same thing here we are doing. So that you remember. So eta we have got. After finding eta, we find E1. E1 is nothing but an identity matrix, but only the first column is different. Okay. Once we have defined E1 and we find BC inverse equal to E1 into B inverse. See, the B inverse and B are identity matrix. If you multiply, you will have the same. So our BC inverse is nothing but our E1. BC inverse is nothing but E1. Initially it is E1. In some other problem, it will not be E1 or E2. It will be something different. Okay, we'll discuss. This is clear? Yes or no? If you tell yes, I'll go to next example. Because anyhow, we are going to solve problem. Okay, we are going to solve problem. So if it is not clear, then there will be confusion and you will not be able to solve any problem. Okay. So next example. So next example, see example 2, I am changing here the two different matrix B and BC. Now you compare. First column is same. B and BC first column is same. Second column here 0, 1, 0. So second column in BC 2, 2, 4. And third column 0, 0, 1. And third column here 0, 0, 1. So which column is different? Which column is different? Yes.
Second column.
Second column is different. Earlier it is first column, second column is different. Now what you should do? So second column is different. R equal to 2. We take C2. C2 equal to 2 to 4. Second column. Okay. Now with respect to C2, what you will do? So our E equal to B inverse into C2. E equal to B inverse into C2. See, B is nothing but an identity matrix in the very beginning. You can see here. Okay. So B is nothing but an identity matrix. Its inverse is also identity matrix. Okay. B inverse into C2 is same as C2. B inverse into C2 is same as C2. The elements are 2, 2, 4. Why I am writing in this fashion? Because see, always you will not find we have the B. See here B and BC. B and BC. B is an identity matrix. Okay. BC only one column is different. For example, I am considering B. This is not an identity matrix. Let us say this is not an identity matrix, but its inverse is known. Here its inverse is known. It is obvious. The identity matrix has same inverse, but B and B inverse, if they are known, we can find BC. B and B inverse is known, we can find BC. But here the extra thing. So since the identity matrix inverse is known, obvious, nothing is mentioned. Okay, but in other example, you will find B and B inverse, they are not identity matrix, they are different. Okay, so that is the reason we have to write in this fashion. Okay, so we have got C2. C2, the elements are 2, 2, 4. So this you can say the elements are E1, E2, E3. Now with respect to E1, E2, E3, eta will be, we can define eta in this manner. Eta will be, for the middle element, this will be 1 by E2. Okay. First element will be, so E1 by E2 with a minus sign. Third element, that is E3 by E2 with a minus sign. And this E2 cannot be 0. It is non-zero. 2, 2, 4. Because with respect to second column, we are pivoting at the second element. With respect to the first column, earlier we were pivoting at the first element. You can see here. Our eta was half, minus 1, minus 2. Half, minus 1, minus 2. Now, it is something different. What is that? That is minus 1, half, minus 2. Minus 1, half, minus 2. Okay. Once eta is defined, we defined E2. What is E2? E2 is nothing but an identity matrix. This is an identity matrix. The second column is nothing but our eta. Second column is nothing but our eta. So the second column, the elements are minus 1, half, minus 2. Other two columns same. This E2 is nothing but an identity matrix, but only one column. That is the second column is different. Okay. So E2 is defined. Once E2 is defined, we can find BC inverse equal to E2 into B inverse. See, B inverse is nothing but an identity matrix. So BC inverse is nothing but our E2. So E2 means the elements of the BC inverse will be 1, 0, 0, minus 1, half, minus 2, 0, 0, 1. Okay, this is clear. Now I'm coming to third example. Is there any difficulty? Any doubt? Hello? Any doubt you find here? Are you able to hear?
Yes, sir.
Okay. So now Let us come to the third example. Third example. See, B and BC. The same column I am repeating. So in first attempt, I have considered in the first column. I am replacing in the first column. In second attempt, I am replacing the second column. So in third attempt, I am replacing in third column. Okay. Why? Why? Because with respect to one entering vector, let us say we have three basic variables. My basic variables are S1, S2, S3. Basic variables, the slack variables. Okay. With respect to three basic variables, S1, S2, S3. If S1 is a departing variable, S1 is the departing variable, then we will replace in the first column. If S2 is the departing variable, we will replace in the second column. If S3 is the departing variable, we will replace in third column. I am repeating again. Let me say my entering vector is 2, 2, 4 and basis matrix is 3 by 3. There are three basic variables. I have given several examples, several problems. You will find in some problem there are two basic variables, in some problem there are three basic variables. Let us consider a problem which has three basic variables. So basic variables are in a serial manner, let us say S1, S2, S3. S1, S2, S3. With respect to S1, S2, S3, you will find a basis matrix B, three columns. The columns are 1, 0, 0, 0, 1, 0, 0, 0, 1. If S1 is the departing variable, okay, then what will happen? You replace in the first column and compute the inverse. If S2 is the departing variable, you replace in the second column and compute the inverse. If so, S3 is the departing variable, you replace in third column and compute the inverse. Okay, that is the reason I am considering three different examples. This now B and BC, which column is different? Which column is different? Compare. Third column is different, yes or no? Third column is different. Since third column is different, so we like to identify what is the third column. The third column elements are 2, 2, 4. That is our E vector, third column. Okay, you can name as so third column. So column 3, that is our two elements 2, 2, 4. So this C3, if you multiply B inverse into C3, you will have same C3. There is no change because B inverse is the identity matrix. That is 2, 2, 4. With respect to this E vector, there are three elements 2, 2, 4. We will pivot at the third element. The 4 is becoming 1 by 4. Then with respect to first element 2 by 4 with a minus sign, half. Then with respect to second element 2 by 4 with a minus sign, that is minus half, and 1 by 4. We have got eta vector. Once eta vector is known, we can find E3. E3 is nothing but an identity matrix whose third column is different, and whose third column is nothing but our eta. Okay, the identity matrix, the elements are 1, 0, 0, second column 0, 1, 0, third column minus half, 1 by 4, E3. If E3 is already obtained, we can find BC inverse. BC inverse equal to E3 into B inverse. That is same as our E3. Is it all right? Now, in my next example, here we find only one column is different. In next example, maybe sometimes you will find there are two columns are different, maybe three columns are different. Then how will proceed? So what is the method? Because this discussion, whatever we have mentioned, this is product form of inverse. See, the product form of inverse, you can see we are taking the product E3 with B inverse, but we are finding since B inverse is nothing but the identity matrix, so ultimately it is becoming E3. Okay. Earlier it was E1, then E2, then E3. Okay, this. See here, the general problem is like this. The general problem is like this. So let B be the basis B be a basis matrix of size m by m. Okay. Initially, the basis matrix is nothing but an identity matrix. Okay. B and B inverse, they are identity matrix. Now I'm defining. So m number of non-singular matrix, because generally we compute the inverse of non-singular matrix. It cannot be singular. Okay. So what the example I have taken here, you can see in the example 1, 2, 3, 3 example. BC. The BC, this in the first example, is it a singular matrix? We have computed the inverse. Is it a singular matrix? Yes or no? It is non-singular in example 1. In example 2 also, it is non-singular. Example 3 also, non-singular. Okay. So we are computing the inverse of non-singular matrix. So here, see the same rule, singular matrix has no inverse. So only non-singular matrix you can find the inverse. Okay. This general problem. So let us say B1, B2 up to Bm, there are m number of non-singular matrix of size m by m. Okay. Now I'm considering in this manner B and B1, they are two different matrices, are differing by first column only. Okay. Both B and B1, they differ by the first column. Then B1 and B2, they are differing by second column. Okay. B1 and B2. B2 and B3, they are differing by third column. Similarly, B3 and B4, they are differing by the fourth column. Okay. Similarly, Bm-1 and Bm, they are differing by the last column. Okay. Is it all right? Now, see, as I have already told earlier, so we can find the B. What is B here? What we have taken B? B is nothing but an identity matrix. Yes or no? Initially, B is identity matrix, but this B1 is a different matrix. It is non-singular and first column is different. So we are interested to compute the inverse of B1. B1 inverse will be equal to E1 into B inverse. E1 into B inverse. But since B inverse is nothing but an identity matrix, so our B1 inverse will be simply E1. Is it all right? Now the question is, what is E1? E1 is an identity matrix. Okay, is an identity matrix. So its first column we are replacing with eta vector. The first column we are replacing with eta vector with respect to C1. With respect to, say, because I have told the first column is different. With respect to the first column, we are finding E1. So we are finding E, then we are finding eta. So in E1, in the first column, we are replacing with the eta. So finally, we are finding B1 inverse equal to E1. Do you accept this one? Hello? Are you able to hear?
Yes.
Anybody there or not?
Yes, sir. Yes.
So we are finding B1 inverse equal to E1. Now I have told you, so B1 is known to us, its inverse is known to us. So B1 is known, its inverse is known. Once B1 and B inverse is known to us, we are interested to find B2 inverse. B2 inverse equal to, in the similar manner, we will find here B2 inverse equal to E2 into B1 inverse. See, earlier you have taken B1 inverse equal to E1 into B inverse. That is E1. B2 inverse equal to E2 into B1 inverse. But B1 inverse equal to E1. So our B2 inverse will be E2 into E1. Is it all right? You can write. So I am going to next example. I will demonstrate there. So our B2 inverse equal to E2 into E1. Similarly, we can find B3 inverse. B3 inverse equal to E3 into B2 inverse. So B3 inverse equal to E3 into B2 inverse. What is E3? E3 is an identity matrix where the third column we are replacing with eta vector and we are multiplying B2 inverse. As a result, B3 inverse is becoming E3 into E2 into E1. Similarly, B4 inverse is nothing but E4 into B3 inverse, that is becoming E4 into E3 into E2 into E1. If you continue in the same manner, you can write Bm inverse equal to Em into Bm minus 1 inverse, that is Em minus 1 and so on, say finally up to E1. And what is E1, E2, E3 up to Em? They are actually identity matrix. Only one column is different. For example, so in E1, first column is different, that we are replacing with eta vector. So in E2, second column is different, we are replacing with a new eta vector. These eta vectors are different, depends on the problem. Then E3, the third column is different, there is identity matrix and so on, say. So we are finding E1, E2 up to Em. Okay, so this Em into Em minus 1 and up to E1, if you multiply, then we are finding Bm inverse. What is Bm inverse? What is Bm? See, if you compare B and Bm, so we'll find all the columns are different. Okay, so now see here. The example 4. The example 4, it will clarify everything. Now I have taken a matrix of size 3 by 3. We are interested to find the inverse, B and B inverse. They are identity matrix. So if you compare B and B1, what is different here? What is different? B and B1. Hello? Now compare B and B1. What is the difference?
The first column.
First column is different. Now compare B1 and B2. Compare B1 and B2. Which column is different?
The second column.
Second column is different. Compare B2 and B3. Which column is different?
Third column.
Third column is different. Now compare B and B3.
All three are different.
All three are different. Now we have got a new problem, say, because when you compute the inverse, So using B, we are computing B1. Okay. Using B, you are computing the B1 inverse. Using B1 inverse, you are computing B2. Okay. Then again, using B3, using B2, we are computing B3 inverse. So as a result, you can see here, if compare B and B3, all are different. Now, using B, how can you find B3 inverse? Directly, it is not possible. We have to go using these steps. Using B, you will compute B1 inverse. Using B1 inverse, you will compute B2 inverse. Using B2 inverse, you will compute B3 inverse. So B3 inverse, B3 inverse, once you have computed B3 inverse, so means it is clear that it is possible. Once one column we are changing at a time and we are computing the inverse. Okay. So now see B and B1. B and B1. Can you tell me what is the B1 inverse? Using B, and if you are computing the B1 inverse, what is our B1 inverse? I have told you. See, the only one column is different. So if you compare B and B1, C1 equal to 2, 0, 0. So once we have obtained this column C1, the 2, 0, 0, we multiply with B inverse. So our E is becoming B inverse into C1. So it is same as 2, 0, 0. Now with respect to 2, 0, 0, what we will do? So we will find eta vector. Eta vector, this 2 is becoming the reciprocal half. Then we are dividing this 2 with other element with minus sign. As a result, we are finding half 0, 0. Half 0, 0. This eta vector. Now, what is our E1? E1 is nothing but an identity matrix. The first column we are replacing with eta vector. Half 0, 0. And second column, third column, same. Only first column is different. Now, with respect to the E1, we'll find B1 inverse. B1 inverse equal to E1 into B inverse. In first attempt, our B1 inverse is nothing but our E1. Half 0, 0, 0, 1, 0, 0, 0, 1. That is our E1. Is it all right? B1 inverse equal to E1. Okay. Now, see here. So we have computed B1 inverse. B inverse is known to us. B1 inverse you have computed. Now we are interested to compute B2 inverse. So when you compute B2 inverse, we will use B1. When you compute B2 inverse, we will use B1. Now, if you compare B1 and B2, which column is different? Which column is different? The second column is different. First column same. Okay. Third column same. But so second column is different. The second column elements are 4, 2, 6. 4, 2, 6. Now that is our C2. See here, our C2 is nothing but 4 to 6. With respect to 4 to 6, what we'll do? We are using B and B2. Sorry, B1 and B2. B1 and B2. So this B1 is known to us. And recently we have computed B1 inverse. Recently we have computed B1 inverse. We are interested to compute B2 inverse. So what is B1 inverse here? B1 inverse, the elements are, the column wise half 0, 0, 0, 1, 0, 0, 0, 1. B1 inverse into C2. Earlier we were multiplying B inverse into C2 because only one column was different. Now here we have two columns are different. So B1 inverse into C2. That is half 0, 0, 0, 1, 0, 0, 0, 1 multiplied with 4, 2, 6. When you multiplied 4 to 6, what is happening? What is happening to this first row, first column? That is 2, then 2, then 6. It is not remaining as 4 to 6. It is becoming 4, 2 to 6. We have got E vector. Once E vector is known, we'll find eta vector. What is eta vector? This eta vector, as you know, we are pivoting at the second element. So the 2 becoming half, then 2 by 2 with a minus sign -1, 6 by 2 with a minus sign -3. The elements are -1, half, -3. Eta vector is known. Once eta vector is known, so we are going to find E matrix. E matrix is nothing but an identity matrix whose second column is nothing but our eta. So elements are 1, 0, 0. The middle column -1, half, -3, 0, 0, 1. So we have got E2. Once E2 is known, we are interested for B2 inverse. Our B2 inverse equal to E2 into B1 inverse. The previous inverse we are multiplying. So this B1 inverse is nothing but our E1. So our B2 inverse is becoming E2 into E1. This is our E2 and this is our E1. And if we multiply it, we are finding B2 inverse equal to, the elements are half, 0, 0, -1, half, 3, 0, 0, 1. So we have got in this example, what we have got? We have got B1 and B1 inverse, B2 and B2 inverse. So finally, we are interested for B3 inverse. B3 is known. So now compare B3 and B2. What is different here? If you compare B3 and B2, which one is different? Which column is different?
Third column.
Third column. So since third column is different, so in the last attempt, we are going to compute what? We are going to compute this, you see here. Our C3 is 005. With respect to C3, we are going to compute the E vector. E vector is nothing but B2 inverse into C3. B2 inverse into C3. That is B2 inverse into C3. We have B2 inverse like this. We have computed already. Half, 0, 0, -1, half, -3, 0, 0, 1. So we have got here multiplied 0, 0, 5. First row, first column. Okay. We have 0, second row, first column. Okay. 0, this third row, first column, this 5. We have got 0, 0, 5. This E vector. With respect to E vector, we will define eta vector. This eta vector is nothing but 0, 0, because we are pivoting at the third element, 0, 0, 1 by 5. Once eta vector is known, we define E3. What is E3? E3 is an identity matrix. First two columns are same. Third column is different. 0, 0, 1 by 5. These three columns are defined. Once E3 is defined, we are interested to find B3 inverse. B3 inverse equal to E3 into B2 inverse. That is E3 into E2 and E1. So E3, E2, E1. The product of three different matrix E3, E2, E1. So these together gives B new inverse because we have changed all the three columns. So our B new inverse, if you multiply this, this is becoming half 0, 0, minus 1, half minus 3 by 5, 0, 0, 1 by 5. Okay, this is our P new inverse. So what you have obtained means we are computing the inverse of the matrix recursively. As a result, we are finding that is B1, B2, B3. B3, once I'm saying B3, that is B new. For example, we are interested to find the inverse of B3. How can you find? So what we'll do here, there are three columns. So we'll compare B with B1. We'll define B1. So then we'll compare B1 with B2. We'll define B2. So then after computing B1 inverse, B2 inverse, then you can compute B3 inverse. So B inverse is given to us. B is nothing but an identity matrix. Using that, we are computing B1. Using B1, we are computing B2. Using B2, we are computing B3 inverse. Okay, that is same as B new inverse. That is the steps. Is it all right? Or any problem? Please tell me. Would you like to discuss more? Hello? Any difficulty you are finding here? Okay, if there is no difficulty, we will go to the revised simplex method. Okay, in the revised simplex method, what we are going to do? So we are computing the inverse of the basis matrix. So recursively, using the identity matrix, you are finding inverse of the B1, then we are finding inverse of B2, then we are finding B3 if the basis matrix of size 3 by 3. See, it is not necessary that you will compute the basis or you will compute the inverse by changing 3 columns. It may happen. So after one column, after changing one column, we are finding the solution, optimal solution. No harm. Maybe after changing 2 columns, we can find the optimal solution. Depends on the problem. So we'll discuss some problem, and first we'll discuss the revised simplex method. Okay. If any doubt, you can ask me here. I will explain. Okay. So we are going to discuss the revised simplex method. So actually, what we have learned already, same thing we are doing using a matrix, using the inverse of the matrix. The original simplex method, in original simplex method, we calculate the simplex table and store it. Okay, so the many tables are not needed in the revised simplex method. The revised simplex method, that is more efficient for computing. It is used all the commercial packages like say IBM, MPSX, CDC, then Apex3, etc. We use all these, the revised simplex method in the commercial package. Say, I have already told you in the revised simplex method, we are using product form of inverse. Product form of inverse for computing. See, for simplicity, I am using a linear programming problem. Only slab variables we are using for our basic variable. Only slab variables. The surplus variable, artificial variables are not there. Okay, so that it will be easier to compare and easier to use. Okay, so what is the problem here? Problem is something like maximize z equal to C transpose into X. So, and how the constants are defined here. So X is less than or equal to B, B is non-negative, the X is non-negative. These are linear programming problem. Since the constants are all less than or equal to type, we need only slab variables. No surplus variable, no artificial variables. Okay. So this problem you can write in the standard form. This problem generally, this linear programming problem has n number of variables and m number of constants. Small n number of variables and small m number of constants. This. So if you are adding slug variables, there will be slug variable. So m number of slug variables. The slug variables are the basic variables. So see, the slug variables are the basic variables. So we can write in this form. So since we are using only slug variables, we have a basis matrix or basis matrix generally. So of size m by m. Initially, the basis matrix, as you know, is a identity matrix of size m by m, and its inverse is also identity matrix. This is the basis matrix. So if you write the numerically, initially, so the elements are like this: 1, 0, 0, 0, all are 0. Then second column 0, 1, all 0, and last column 0, 0, 0, lastly 1. Okay. This is the basis matrix, and this inverse is also same B. So with respect to this, we are going to have the computation. This basic matrix, you know, these are the basic variables. Generally, basic variables are the slug variables. Okay. So as you know, so in the very beginning, when we are formulating the table, there are basic variable and non-basic variables. We set all the non-basic variables to 0. Okay. We set all the non-basic variables to 0. Okay. If you set all the non-basic variable to 0, our problem is becoming b into xb equal to small b. B into xb equal to small b. So our xb equal to, what is xb? xb is the basis vector. That is B inverse, capital B inverse into small b, where B inverse is nothing but the inverse of the basis matrix. At any iteration, given the original vector B and the basis matrix B inverse, this xb can be calculated in this manner. What is our z? Z equal to, once xb is known, z equal to CB transpose into XB. What is CB? CB is nothing but the coefficient of the basic variable in the objective function. Coefficient of the basic variable in the objective function, the CB. Okay, this is a vector. So CB transpose into XB is giving the value of our objective function. So this is the rule. What we are going to do, our xb equal to b inverse into small b. xb equal to b inverse into small b. Okay, this. Initially, b inverse is nothing but the identity matrix. But as you know, if you are going for iteration, new iteration, so we are going to change only one column at a time. Then we are computing the inverse. Changing one column at a time, then we are computing the inverse. Okay. So if you are changing one column, the B matrix is changing and its inverse is also changing. So with respect to that, our XB vector is changing. So many changes are there. So we'll discuss by means of some example. Let me talk about the algorithm. Okay. What is the algorithm? See here, the simplex and the revised simplex method all are same, but here you are using only the basis matrix inverse to compute everything. Okay. Step 1. Step 1 say determine the entering vector xj with the associated vector Pj. See, from these vectors P1, P2 up to P, let us say P and M or P M plus N, whatever it may be. So these are the vectors with respect to basic variable, non-basic variables. Generally, this Pj, we are talking with respect to the non-basic variables. Okay, non-basic variables. So we are going to compute with respect to the associated vector Pj, our y equal to Cv transpose into B inverse. What is B inverse initially? What is B inverse initially? Hello? B inverse initially is an identity matrix. Okay. Our y equal to Cv transpose. This is a, the column vector is a, we are taking the transpose, the column vector. So that is becoming a row vector. Row vector into B inverse. This y is nothing but a row vector. Now, next computation is we are computing Zj minus Cj. That is actually value of the indicator row element Zj minus Cj. Why it is required? If you find there are some negative element in the indicator row, we select the most negative elements. The Zj minus Cj, something say about the indicator row elements. The Zj minus Cj equal to y into Pj minus Cj. This you are computing with respect to all the non-basic variables. There are two categories of variables, basic variables, non-basic variables. Okay. With respect to non-basic variable, we are computing Zj minus Cj. I will explain by means of some example. So after selecting that, select the largest negative value because we are considering maximization type LPP among all the Zj minus Cj element. Select the most negative element. Then break the ties arbitrarily. If there is a tie, you can break arbitrarily. First come first basis you can select. If all the Zj minus Cj are non-negative, optimal solution is reached. Once optimal solution is reached, we compute xb equal to B inverse into small b, capital B inverse into small b, z equal to Cb transpose into xb. If there is no negative suddenly, and we complete and we stop. Otherwise, if there is a negative element, say we go to step 2. What is step 2? Say with respect to the entering variable, we decide the leaving variable. Leaving variable is nothing but a basic variable. This leaving variable we are naming as xr is associated with vector pr. Compute the current basic variable xb. Our xb equal to capital B inverse into small b. Compute the constraint coefficient of the entering variable pj. That is alpha j equal to B inverse into pj. What we are doing in the product form of inverse. B inverse into a column. That is our pj. B inverse into pj. So we have got the alpha j, the column vector. Now leaving variable xr must be associated with theta. Theta is equal to minimum over k. B inverse into small b, the kth component, divided by alpha j, the kth component, and this denominator cannot be 0. It has to be greater than 0 using the minimum ratio rule. If you find all the elements are either 0 or negative, then we say the problem is unbounded. Okay. So next, step 3, that is the determination of the next basis and its inverse. B nest inverse. For a given B inverse, the B nest inverse is computed by the product form of inverse. B nest inverse equal to ER into B inverse, where R is the column number of the entering vector. And what is SB inverse? Then we are saying there, set B inverse equal to B nest inverse. See, once you have computed, so we will set B inverse equal to B nest inverse. Then go to step 1. This ER, what is ER? This is nothing but an identity matrix of size m by m, and only rth column is different. We are replacing with the eta vector. What you have learned. Okay. So when we solve a problem, all the steps will be cleared. So now I'm discussing a small numerical example. Okay. See this numerical example. We are going to maximize z equal to 4x1 plus 2x2 plus x3. These are objective function, and the constants are like this: 2x1 plus x2 plus x3 less than equal to 14, x1 plus 2x2 plus x3 less than equal to 10, and this x1, x2, x3 are non-negative. This is a maximization type problem. The constants are less than equal to type. We introduce slug variables. The slug variables are S1, S2. Then we formulate a simplex table. Formulate a simplex table. Say, here, this is the problem you can see here. This is the problem. Two slug variable S1, S2. With respect to the slug variable, the coefficients are 0, 0. And the constants twice x1 plus x2 plus x3 plus s1 equal to 14, x1 plus 2x2 plus x3 plus s2 equal to 10. This x1, x2, x3 are non-negative. The slug variables are the basic variables. They are non-negative. This you are placing in a simplex table. And in the revised simplex method, we generally use the extended simplex table. Only one table is required. Only one table. Why one table? Because we are going to compute everything using the basis inverse, B inverse from the B inverse. Okay. So this you are going to place in a simplex table in this manner. This is our simplex table. In the simplex table, there are 5 variables. 3 are basic variables, 2 are basic variable, and 3 are non-basic variable. The non-basic variables are x1, x2, x3. x1, x2 are the non-basic variables. Basic variables are s1, s2. There are 5 columns. First column we are naming as P1. The elements are 2 and 1. Second column 1, 2, P2. Third column 1, 1. And fourth column is 1, 0. And fifth column is 0, 1. Now, from this simplex table, can you identify what is your basis matrix? Can you identify what is your basis matrix? Hello? From this simplex table, can you identify what is your basis matrix? See,
identity matrix.
Basis matrix is nothing but the identity matrix. The elements are, you can see here, 1, 0, 0, 1. Okay, 1, 0, 0, 1. So other elements you can see here 2, 1, 1, 2, 1, 1. Okay. I will explain everything. So here itself, we are just doing some primary calculation. Okay. This in last row of the simplex table, the indicator row, this -4, -2, -1, these are the three elements below the non-basic variables. -4, -2, -1. Below the non-basic variable, there are three elements. Below the basic variable, two elements 0, 0, and that 0 says something about the value of the objective function. Now, can you tell me what is the value of the basic variable in this table? S1, S2. S1 equal to 14, S2 equal to 10, and the value of the non-basic variable x1, x2, x3, they are 0. Okay. This with respect to -4, -2, -1. What is the most negative element? What is the most negative element? Please tell me. -4, -2, -1. What is the most negative element?
-4.
Most negative element is -4. Okay, most negative. The largest negative element in terms of the negative sign here, -4, most negative. So with respect to -4, this x1 is the entering variable. X1 is the entering variable. Once x1 is the entering variable, we say that x1 is the entering with the column. With respect to x1, there is p1, this 2, 1. The column elements, there are 2, 1. This is the entering vector. Now, say once x1 is entering, S1 and S2, one of them will leave, either S1 or S2. Say how to find? Say using the simplex rule, earlier rule I am using here. So 14 divided by 2, the minimum ratio rule. 14 divided by 2, how much? 7. 10 divided by 1, 10. Minimum ratio is becoming 7. With respect to 7, this 2 is our key element. This 2, right? This 2 is your key element. So with respect to 2, x1 is entering. So which one will depart? So S1 will depart. Means x1 is the entering variable. That is a non-basic variable. In the next table, it is becoming basic variable. S1 is the basic variable. In the next table, it will become non-basic variable. So the role will change. X1 is becoming basic variable. Then S1 is becoming non-basic variable. Now see here, with respect to x1, this is the column 2, 1. With respect to x1, the column is 2, 1. Now the basis matrix, there are two columns, 1, 0, 0, 1. S1 is a leaving vector, leaving variable. With respect to S1, one vector will move. That is the 1, 0. This 1, 0, this two element 1, 0, we can replace with 2, 1. Why? See, with respect to S1 and S2, there are two different columns, 1, 0, 0, 1. So the position was first column. S1, we have made S1 is the first basic variable. So with respect to S1, we have the first column here. This first column will replace by 2, 1. Once you replace, so the first column is becoming 2, 1, and the second column becoming 0, 1. That is our new basis matrix. New basis matrix. With respect to new basis matrix, we can find the inverse. Yes or no? What will be the inverse? Can you tell me? What will be the inverse? Once you are replacing 1, 0 with 2, 1, what is our inverse? This inverse will be this 2. 2 is becoming the reciprocal. 1 by 2, then minus 1 by 2. Second column there is no change, 0, 1. So new basis matrix inverse is nothing but 1 by 2 minus 1 by 2 first column, second column 0 and 1. That's all. Okay. So here what we are doing, we are finding a new basis in inverse using the product form of inverse rule. Okay. So from this table, I'm going to explain. In this example, so we'll follow all the steps here. Or initially our basis matrix, you know, the elements are 1, 0, 0, 1. Is fine initially. So it's inverse 1, 0, 0, 1. CB transpose. What is CB transpose? You can see here. CB transpose, this is CB. CB I'm saying in terms of a column vector 0, 0. CB transpose is the row vector 0, 0. CB transpose 0, 0 is given 0, 0. Okay. So with respect to 0, 0, we are defining y. Y equal to CB transpose into B inverse. Y equal to CB transpose into B inverse. B inverse 1, 0, 0, 1. If you multiply, how much you are finding? 0, 0. The elements are 0, 0. CB transpose 0, 0. So our y equal to CB transpose into B inverse, that is also 0, 0. Fine. Now we have basic variables. What are the basic variables? S1, S2. Non-basic variable X1, X2, X3. For all the non-basic variables, calculate Zj minus Cj. Zj minus Cj. This equal to y into Pj minus Cj. Zj minus Cj equal to y into Pj minus Cj. Okay. Y into Pj minus Cj. This is, what is our y vector? Y vector is 0, 0. That is a row vector 0, 0. Y into Pj, P1. P1 is 2, 1. How much? 0, 0. Inner product with 2, 1. That is 0. 0 minus 4. That is minus 4. Similarly, 0, 0 with P2. 1, 2. That is 0. 0 minus 2. That is minus 2. Then 0, 0. Inner product with 1, 1. That is 0. 0 minus 1. That is minus 1. Okay. So we have got minus 4, minus 2, minus 1. Clear? This below the basic variable, we have 0, 0. We are not calculating, because if you calculate, it will be 0, 0 also. 0, 0 with 1, 0, that is 0. 0 minus 0 is 0. 0, 0 with 0, 0, 1, that is 0. Minus 0, this is 0. And 0, 0 with 14, 10, that is 0. This. So we have got minus 4, minus 2, minus 1. So among minus 4, the most negative among the three elements, minus 4 is the most negative. So x1 is selected as the entering variable. X1 is selected as the entering variable. So once xj is selected as the entering variable, we are interested for the departing variable. Step 2. What is step 2? Xb equal to B inverse into B. Presently, B inverse is nothing but the identity matrix. Xb equal to B inverse into B. If you multiply, so we are finding the elements are 14 and 10. And what is alpha 1? Alpha 1 equal to B inverse into P1. The alpha 1 has two elements, 2, 1. Okay, B inverse into P1, 2, 1. Now we have the minimum ratio rule. What is the minimum ratio rule? So we have here 14 by 2, 7. 10 by 1, 10. Minimum ratio is 7. So once it is, you have got 7, row number 1. We are finding this is happening at row number 1. So S1 is selected as the departing variable. So once S1 is selected as the departing variable, so with respect to row number 1, the first column you can see here, first column of the basis matrix 1 0 0 1, first column. Here it was first row, S1 with respect to first row, S2 with respect to second row. But here there are two columns, S1 and S2. So with respect to this S1, we have S1 here. With respect to S2, the S2 here. Since S1 is the entering departing variable, so the first column 1 0 we are replacing with 2 1. First column 1 0 we are replacing with 2 1. Then we are computing the new inverse. Okay, this. Our B nest, initially B was 1 0 0 1. Now once you have replaced 1 0 with 2 1, B nest basis is like this: 2 0 1 1. Row wise 2 0 1 1, or you can say 2 1 1 0 1. This. So once B nest is known, we can find this inverse. What is the inverse? B nest inverse equal to 1 by 2 minus 1 by 2 0 1. Okay. So this is our B nest inverse. Then what we will do? Our new B inverse, that is B inverse. So we'll replace with B nest inverse. Okay, this. Now we'll go to step 1. Step 1. What is the step 1 here? See, B equal to 2 0 0 1, 2 0 1 1, or you can say 2 1 0 1. B inverse is like this: 1 by 2 minus 1 by 2 0 1. Okay. Now once this is known, we are interested for CB transpose. CB transpose. What is CB transpose here? I want to explain. See, x1, what is the coefficient? X1, the objective function coefficient is 4. This x1 is coming to this position. This x1 in the basis matrix is taking this position. So of S1, the coefficient will be 4. This S2 coefficient is 0. That remain. The coefficient is becoming, instead of 0 0, it is becoming 4 0. The coefficient is becoming 4 0. You can see here. The coefficient is becoming 4 0. Now 4 0 we are multiplying with, that is CB transpose into B inverse. Earlier we are multiplying with the identity matrix. Now we are multiplying with the new inverse. That is, the elements are row wise half 0 minus half 1. So if you multiply CB transpose into B inverse, we find here this element is becoming 2 0. Okay. So once you got 2 0, so what are the non-basic variables? Basic variables are presently x1 and s2. S1 and x2. These are the basic variables. Okay. x1 and s2. These are the basic variables. Non-basic variables are x2, x3 and s1. x2, s3, s1. These are the non-basic variables. Two basic variables, x1 and s2. So what we are going to do? So next we are computing Zj minus Cj, which is nothing but y into Pj minus Cj for all the non-basic vector. The non-basic vectors are P2, P3, P4. P2 with respect to x2, P3 with respect to x3, P4 with respect to s1. So this is becoming like this. So C2 minus Z2 minus C2 is becoming 0. Z3 minus C3 is becoming 1. Z4 minus C4 is becoming 2. As a result, what you are finding? All the elements are either 0 or positive. Okay. Z2 minus C2 equal to 0. Z3 minus C3 equal to 1. Z4 minus C4 equal to 2. So we find that all the Zj minus Cj elements, they are non-negative for the non-basic variables. Now the conclusion say we have got the optimal solution. What is the optimal solution? Our optimal solution xb equal to the vector, the basis vector, basic variable x1, s2, that is b inverse into small b, b inverse into small v. So if you see here, our xb, b inverse into small b, this is the b inverse. Small b equal to how much here? 14 and 10. 14 and 10, if you are multiplying the vector, so this is giving 7 and 3. 7 and 3. Once xb is known, our z equal to cv transpose into xb. 4073, that is 28. Now, once xb is known, that is 28, and the objective function value is, that is xb equal to 73, and objective function value is 28, we have got optimal solution. What is the solution here? x1 equal to 7, non-basic variable, x2 equal to 0, x3 equal to 0, then the basic variable s2 equal to 3, s1 equal to 0. So we have got a solution. And further we observe, see, there is elements like Z2 minus C2. The indicator of one element is 0. The 0 indicates there may be alternate optimal solution. And we have an alternate optimal solution, Z2 minus C2 equal to 0. So with respect to this, we have alternate optimal solution. Our alternate optimal solutions is like this. x1 equal to 6, x2 equal to 2, and with respect to 6 and 2, our objective function value is also 28. Okay, this. So what we have done, now let us know the summary. What we have done here. With respect to this problem, this is the problem, we are formulating a simplex table. Okay, only one simplex table we are formulating. Now, so in the simplex table, we know that this basis matrix is nothing but an identity matrix, and its inverse is known. If you change one column, so what will happen? What will happen to, say, the new basis matrix inverse? See, in this problem itself, I will tell you. So we have got 1 0 here. What is that? We have got 1 0. Z2 minus C2 is 0. Z2 minus C2 equal to 0. With respect to 0, so our conclusion is there is alternate optimal solution. Alternate optimal solution. So what is happening? This, the basis matrix, initially it was, 1 0 0 1. So next time what you have done? We have replaced the first column with 2 1. So if you replace first column with 2 1, we have got the inverse. Now second time, so there is a possibility that there is optimal solution. So why it is so? The reason is, once we are saying, let us say, below this x2, z2 minus c2, in the second attempt, we have got 0. 0 means, so this column, what is this 1, 2 may be changed. This 1, 2 will change. So this 1, 2 column, we are going to change. Where we will change? So in the basis matrix, there are two columns, 1, 0 and 0, 1. First column we have changed. Second times, whether in the first column itself or in the second column, we want to know. So for that, we have to do some calculation. What is the calculation? So this 1, 2, this 1, 2 is multiplied with this matrix, B inverse. Multiply 1, 2. If you multiply 1, 2, what will happen? Okay. We are multiplying 1, 2. 1 and 2 in the right hand side. So first column becoming half, second column, okay, 2 minus half, that is 3 by 2. First column is half, then it is 3 by 2. So we have got two value. Now, with respect to this B nest inverse, in the right hand side, you multiplied 10 and 14. 14 and 10. It's 7, 3. Now, with respect to 7, 3, you take the minimum ratio. So the elements are, so first element is half, second element is 3 by 2. We have got two elements. One is 7, other is 3. If you divide by half, the first element is becoming 14, second element is becoming 6. Minimum ratio is 6. So minimum ratio 6 says this. So second element, so second row, that basic variable S2 will leave. As a result, in the second column, there is some changes here. So in the second column, earlier it was 2, 1. Now it is 1, 2. This 0, 1 we replace with 1, 2. 0, 1 we replace with 1, 2 and compute the inverse. See, already it is optimal, I have mentioned. But now there is an option that this problem has alternate optimal solution. With respect to Z2 minus C2 equal to 0, so we are going to compute the new inverse. New inverse, how to compute? So 2, 1, the first column is 2, 1, second column is 1, 2. 2, 1 and 1, 2. So 2, 1 and 1, 2 is the symmetric matrix, but you apply the product form of inverse and compute the inverse of the basis matrix and use. So what will happen? What will happen to the basis matrix inverse? One is 2, 1, another is 1, 2. What is the inverse? Tell me. First column is 2, 1, second column is 1, 2. What is the inverse? Yes. Anybody? 2, 1 and 1, 2. See, earlier it was 1, 0, 0, 1. Now this 2, 1 and 1, 2. These two becoming our basis matrix. So the inverse, as you know, this will be 2 by 3. Okay. Minus 1 by 3. Minus 1 by 3, 2 by 3. Now this 2 by 3 minus 1 by 3. This 2 by 3 minus 1 by 3 multiply with 14 and 10. So how much it will be? Two by 3, 14 into 2 by 3. (28 by 3) minus 10 by 3, 18 by 3. 18 by 3 means our x1 is becoming 6. Similarly, so second one, that is 1/3 and 2/3. 1/3 means, so 2/3 means 20 minus 14, 6. 6 by 3, that is 2. So as a result, our solution is becoming, you can see here, 620. 620. We have verified. So this is a solution. What is the solution? The 7, 3, x1 is 7, x2 is 0, x3 is 0. That is a solution. The second attempt we have got x1 equal to 6, x2 equal to 2, and x3 equal to 0. Another solution. The z is not changing. Since z is not changing, see our CV. What is our CV? This CV we have got the CV earlier. It was, this is coming here. So the x1 coefficient is becoming 4, x2 coefficient is 2, 4 and 2, and the variable x1, x2, the 6 and 4, the optimal solution. So 6 into 4, 24, 2 into 2, that is 4, 24 plus 4 is 28. So we have got the objective function value is 28. Okay. So what I'm saying here, using this revised simplex method rule, you can solve other problems. So we have several problems here. I have arranged here. You can see this is one example. You can see this, a similar problem. So you can solve using the revised simplex method. R2, then R3. This two variable problem. Two constants are there. So basis matrix of size 2 by 2 you will have. The fourth one also size 2 by 2. Fifth one is also size 2 by 2. But sixth one, again I'm keeping same 2 by 2. But now you see here seventh one. This basis matrix of size 3 by 3. Then the eighth one also 3 by 3. So ninth one again 3 by 3. So 10th one also 3 by 3. So we are going to calculate this basis matrix and this inverse. Now, how we are going to calculate? We are using the product form of inverse. So if any doubt here, you can ask, I can explain. Hello? This example is clear or any problem? Hello? You are there or left? Can you hear?
Yes, sir.
Any problem in this example, numerical example? See, once a problem is given, you present the extended simplex table. Extended simplex table. So in this revised simplex method, mainly I have demonstrated with a problem with all constants are one type, that is less than equal to type. And most likely in the problem itself, you are using slack variable. If surplus variable, artificial variables are there, then you will have revised simplex method. But of course, you have to use the method for the big M, not two phase, big M. Okay. So since big M, as you know, it is somewhat lengthy, so I have made it simple. So only slack variables are introduced. Only slack variables. So once a problem is given, formulate only one table, then what exactly you are going to do? Initially, basis matrix, either it is 2 by 2 or maybe 3 by 3 or maybe 4 by 4, depends on the problem. This and the inverse, both are known to us because this basis matrix inverse is also an identity matrix. Now, with respect to the basis matrix, we have here the CV. What is CV? CV is nothing but the coefficient of the basic variable for the objective function. So once we have defined all these things, then other thing we are computing using the B and B inverse. Using the B inverse. Y is nothing but CV transpose into B inverse. Okay. Once Y is computed, then for all the non-basic variable, we are computing Zj minus Cj. Zj minus Cj, that is equal to Y into Pj minus Cj. Here, this P1, P2 are not defined. What is P1? P1 is the first column for the non-basic variable. P2 is the second column for the non-basic variable. P3 third column. P4 is the fourth column. And P5 is the fifth column. The P4 and P5, they are presenting with respect to basic variables. P1, P2, P3 are the non-basic variables. So among the 5 variables, 2 variables will be basic variable, the complement. Whatever left out, that is the non-basic variables. Presently, S1, S2 are the basic variable, rest are the non-basic variables. Okay, X1, X2, X3 are the non-basic variable. Then the next attempt, X1 and S2 are the basic variable. Then we have X2, X3 and S1. That is the non-basic variable. In the last attempt, what we have done, X1, X2 are the basic variable. The non-basic variables are X3, S1, S2. Okay, in this manner. So here you have to keep track. What is our CV? Then what are the basic variables? What are the non-basic variables? Then say how to compute which one is the departing variables. So where you are replacing the entering vector column, and then we are computing the inverse. Then we are setting our old inverse and new inverse. New inverse is nothing but our old inverse. We are replacing, then we are computing. Okay, that's all. So these are the things you have to remember, and most likely here itself you are using product form of inverse to compute the inverse of the basis matrix. Why? What is the reason? Because once one old inverse is there, so that inverse you are using only changing one column and you are computing the inverse. Okay, so please use the product form of inverse in the revised simplex method. In all the problem, use the product form of inverse and simplify. Okay, if any doubt, you can ask me, I will explain. Hello? So I am thinking, so around 15th of this February, I will take a test. Is all right? Syllabus, whatever we have covered up to maybe around 10th of February, that is included. I will communicate, and the test will be half an hour as per the institute guideline, and this will be objective type test. Okay, right?
Yes, sir.
So can you try one problem? The second problem, can you try? See, I have basically in this revised simplex method, I have taken so either 3 variable problem or maybe 3 constant problem. So 3 variable, 3 constants. So see, whenever you are computing the inverse, you have to apply the basic rule. What is our basis matrix? Okay, so what are the basic variables? Okay, so you can take in some book they have let us say there are 3 variables x1, x2, x3. The basic variable will be either s1, s2, or you can say x4 or x5. Okay, so make it s1, s2 so that you can remember these are the basic variables initially. Okay, so with respect to s1, s2, you formulate the problem, then proceed. So initially for 2 by 2, the basis matrix is an identity matrix of size 2 by 2. For 3 by 3 problem, a basis matrix is nothing but an identity matrix of size 3 by 3. Here it is 2 by 2. Okay, so there are few problems where you can have basis matrix of size 3 by 3 and some problem where you will have basis matrix of size 2 by 2. So other steps remain as it is, but only formulate one simplex table and try to write down the steps, what you are doing. So in step 1, step 2, in step 1, step 2, what are the basic and non-basic variable? So if you move again next round, say what are the non-basic variable at a times, one is entering and one is leaving. So with respect to that, we are changing the inverse. So with respect to your computing, so it will be very simple to remember, but only everything you will do in terms of the inverse of the basis matrix. Okay, that's all. Thank you. So I will stop here. And these slides I will send to you. Okay. Any query?
Sir, what is the date of test? Can you repeat once again, please?
What is the
Date of the test you were talking about? Can you repeat once again, please?
only you are interested for the test? So around middle of February.
Okay, sir.
So
Thank you.
I'm going to take the test on either Tuesday, not Monday. Tuesday will be ideal time. So 1 hour, so maybe half an hour will go. Okay. Middle of February. Okay. Okay. Thank you. I will stop here.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.